This is day 2 of your lesson on circles and ellipses. It's just formalizing the notes that we did on Friday. So we're going to first start with a circle. And a circle is a set of points that are all equidistant from a given point called the center. The distance from the center to the point, to any point on the circle, is called the radius. The graph of the equation in the form, we're going to look at this in general form. That's the general form of it. And I don't have an A and a B in front of the X and the Y because we could have just divided, because both of those have to be the same, whatever they are. So it would be 2 and 2 or 3 and 3. In this case, I have 1 and 1. And if they weren't 1 and 1, you would divide by whatever it was to get all of the other ones. So you just have X squared plus Y squared. By completing the square, you end up putting it in what is called standard form. The standard form is sometimes called the graphing form or the center radius form, but standard form is what we're going to be using in our class. General form, a general form of any conic, and then standard form would be the form we want to put it in so that we can graph it. From this graph, we find that the center is HK, the radius is R, and we're able to put that into our graph. And I just did a random circle here that has a center right here, what I'm calling HK, and then some distance R, and all of those are the collection of infinitely many points that are R units from HK. So we're going to do some examples here. Now, these first ones are in their standard form, their graphing format. So in problem number 1, we can see that what we're subtracting from X is 3. What we're subtracting from Y is nothing. So the center of our circle is 3, 0. Our radius, now remember this equals radius squared, so this is 3 squared, not 9, but 3 squared, which tells us that our radius is 3. From this information, I graph the point 3, 0, and then I go out the distance of 3 units from that, and I have my circle. In problem number 2, I'm noticing here this equals 4. Remember, that's not 4, it's 2 squared. But I'm also looking at what is the center. What am I subtracting from X? What am I subtracting from Y? So, while this is 2 squared, it equals not 4, but 2 squared. I'm not subtracting 5. I'm subtracting negative 5 from Y. So my center is 0, negative 5. My radius is 2. And I graph my circle. This one also is in graphing or standard form. What am I subtracting from X is 1. What am I subtracting from Y? Negative 3, because it says Y plus 3, so I'm subtracting a negative 3. And this doesn't equal 9. I say 3 squared so that I can say that my radius is 3. I put a dot at 1, negative 3, which is my center. I go out 3 units and draw my circle. This last one, problem number 4, we need to complete the squares. So I start by making my party of x's, so I just put a parenthesis around all of the terms that have x. I complete the square by saying, oh, what would I add to complete this? I would add negative 2 squared. But I'm not just adding negative 2, I'm adding negative 2 squared, which is 4, which means on the other side of the equation, to keep it balanced, I have to add 4. This is now a perfect square. It is x minus 2 quantity squared, because that's what I was squaring. I'm going to do the same thing with my y's, make my party of y's. I realized to complete the square, I would add 4 squared, but I'm not adding 4 to both sides of the equation. I'm adding 4 squared to both sides, so I'm going to add 16 over on the right. And now this is a complete square of y plus 4 quantity squared. And outside this 5 that was just sitting here, we don't want any constants over here, so I'm going to subtract 5 to the other side. I can now write the equation in its standard form, which is x minus 2 quantity squared plus y plus 4. Whoops, there should be a little square there. Hold on a second. Here we go, now it's fixed. So we've got y plus 4 quantity squared equals 6. This tells us that what am I subtracting is 2. What am I subtracting? Negative 2. So, actually, negative 4. So I have 2 comma negative 4 as my center. I'm going to put that dot there. My radius, I look at 16 and I know that's 4 squared, so my radius is 4. and then I graph it. All right, we have some more completing the squares. I want you to pause the video and try to do these on your own. And then when you come back, we will look at and check to make sure you have them correct. So again, pause the video, complete the squares for problem number 5, complete the squares for number 6, and then you'll come back to check your answers. Okay, hopefully you have paused, you've done both of these problems, and we're going to go through them very quickly. So to complete the squares for number 5, I have party of x's, and so I was adding 7 squared to both sides, and so I have x plus 7 quantity squared. In the group of y's, I would be adding 1 squared, so I'd be adding 1 to both sides, and then that equals 10, which means my center is -7, -1. My radius is the square root of 10. Now remember, I think of square root of 10 as a little bit more than 9. It's just a little bit more than the square root of 9, which means this radius is a little bit more than 3. Go ahead, graph it, and there I have it. Problem number 6. In problem number 6, I rearranged it so that I could put my party of x's and my party of y's. I add what I need to complete the square for the x's, which is -5 quantity squared. I add what I need to complete the y's, which is 4 quantity squared. And then I simplify. I see my center is 5, -4. My radius is 5, and then graph it. All right, let's move on to ellipse. In an ellipse, we have a set of all the points in a plane. It's the sum of the distances from 2 given points in the plane is called, which is with the 2 points, which are called the foci, is constant. An ellipse has 2 of these axes that cut. They cut straight through the ellipse and make symmetric pieces. And one of them is called the major axis and the other is called the minor axis. I just wanted to remind you to pronounce this word. It is not foci, it's foci. It's foci, okay? And the foci is always on the major axis. The foci follows the major axis, right? The intersection of the major and the minor axes is the center of the ellipse. So here we have an ellipse. The foci would be 2 points on the longer axes, the major axes, that are inside and equidistant to the center. We have 4 vertices. We have the major axes and the minor axes. We have the major vertex, and there's actually 2 of them, so the major vertices, and this one here is a minor vertex, and there's 2 of them, so they're minor vertices. The distance from the center to a major vertex is A. The distance from the center to a minor vertex is B. And the distance from the center to a foci is C. Those are distances, so we just always call them positive, since they are distances, and there's a relationship between A, B, and C, and that is the distance to the foci squared is equal to the difference of the squares of the other 2 distances. So here we have 2 different types of ellipses that we'd see, horizontal and vertical. Look at the equations very carefully. You'll notice in this first one, the horizontal, you've got the A squared underneath the x term. Now the A represents the major axes. The A is the distance on the major axis, and since it is under the x, then the x direction, horizontal, is going to be the larger axis, which means we're going to get a horizontal ellipse. Over here, and for vertical, we notice that the A squared is under the y. So this, again, is the major axis length. It's half of it. It's from the center to a major vertex. And it's in the y direction, which is vertical. So we would end up with a ellipse that looks more up and down. It's stretched top to bottom. Okay. The foci, well, you need to find your C. And since this is going left to right, that would be the major axis, is the x-axis. So to the HK of the center, we're going to add our C to H. We're also going to subtract our C. So we have the 2 foci. To find the vertices, well, we have our major vertices. And our major vertices, we would be adding to the H, the A. And for our minor vertices, we're going to be adding the B to the K of the center. With a vertical, we're still using A, B, and C, but we're not adding into the same part of the center. So for the foci, you're going to be adding to the K in the center, K plus C, and you're also going to do K minus C, and you'll have your two foci. For your vertices, the same thing here. For the major axes, we're going to be adding and subtracting A to the K, and that's going to give us our major vertices. But for our minor vertices, we're going to be adding B to the H. And again, you can kind of see that since B is under X, that's what we're adding the B to and subtracting from to get our minor vertices. Write an equation for each of these. I'm looking at them. I need the center. I need to know my A and my B. Those are the parts I need when I'm looking at a graph. I don't need the C. The C is only used to find the foci. For this, I'm not looking at the foci. I'm just looking at the A and the B and then my center to write the equation. Since my center is 0, 0, and my A is 6 and my B is 3, I know that these are the denominators that I'm going to square underneath. And since this is a vertical, I'm going to be putting 6 squared under the Y of this. Now, this tells me what I subtract from my X and Y, which is nothing, which means I just have X squared, and then I have B squared, 3 squared, which is 9, and then I have Y squared over 6 squared, which is 36, and there's the end of that problem. For this next one, I have the same thing. I have a center of 0, 0, but this time my A is 4, my B is 2, and since this is horizontal, A squared is going to go underneath the X term, and the B squared is going to go under the Y term. In this third problem, I put lines in here so I could figure out where is the center. So I went from the utmost top to the bottom, and that'd be my major axis. So this is a Y or a vertical. So I know my A is going to be under the Y part of the equation, and the B here is the minor axis. From that, I can see that the center of this circle is -1, 2. My A is 5 because I can just count from that point of intersection, count 5 units up. My B is 2, so I have X minus -1, where I wrote as X plus 1, divided by 2 squared. I have Y minus 2 divided by 5 squared, and it equals 1. Problem number 1, here for examples, you're given the equation, we want to write it. We're not subtracting anything from X and Y, so we know that our center is 0, 0. I can see that this is vertical because the larger denominator is under the Y. And so my A is 5 and my B is 2 because you're always taking the square roots. And I did this just to remind myself, oh, I'm going to go from the center up 5 units and then down 5 units. And that's when I will have my vertices, my major vertices. And from the center, I'm going to go left and right 2 units to find my minor vertices. To find my foci, I'm going to go up and down the square root of 21 from the center. And I think of the square root of 21, which is between 16 and 25. So I know I don't need to know the decimal. I don't need to pull out my calculator. I just say this is somewhere between 4 and 5. So I have all of my points that I'm going to put there, my center. I go up a little bit, more than 4, but less than 5 for my foci. I go down a little bit more than 4, but less than 5. I go to my major vertices, up 5, down 5. I go to my minor vertices, over 2, and over to the right 2, to the left 2, and then I make my ellipse. Okay, problem number 2. Problem number 2, this is not in the proper form yet. We need to divide everything by 144. When we do that, we now have it in standard form. So my center is 0, 0. My A is 4. My B is 3. My C is square root of 7, which I know is between 2 and 3. I start putting in all the points. I put the center. I go up, somewhere between 2 and 3, and down somewhere between 2 and 3 for my foci. I'm not up and down, I'm sorry. This is left and right because this is a horizontal. So I have it there. And so this is my major axes. And then I have my minor vertices here in green. And then I connect and make my ellipse. For problem number 3, well, we need to complete the square. There's only one square that needs to be, the x is already complete. There's only one term with x, and it's x squared, so this is a complete square. But the y is not a complete square because I have 2 terms with y, so I need to go through the process of completing the square. I factor out that 4, that's important, and then I have 6y, half of that is 3 squared. So here's what I plugged in to complete this square. But I didn't add 3 squared, I added 3 squared times 4. So 9 times 4 is 36. So I had to add 36 to the right side. I write it now in standard form where I've got my complete square of x squared. I have my complete square of y plus 3 quantity squared. It is being multiplied by 4, and this equals 4. It can't equal 4, so it's not actually in standard form yet. I need to divide all terms by 4, so I divide the x squared term by 4. I divide the y squared part by 4, and I add the 4 by 4 and simplify. Now it is in standard form. So the larger denominator is under the x. This is horizontal. I'm going to be going 2 units to the left and right of the center. The denominator for the y is 1, so I'm going to square root of that is 1. So I'm going to go up and down 1 from the center. The center is, what am I subtracting? I'm subtracting nothing, so 0, and I'm subtracting negative 3. So I have a center of 0, negative 3. I have my a and my b. My c is between 1 and 2. And I go ahead and I start putting my points in and then draw my ellipse. That's the end of our guided notes. I want you then to take the handout that is given by the sub and work on the handout for the rest of the period with your partners. It is due before we meet next.